So I'm Greg, here to introduce the next speaker. In Flux, you'll see that there's a new Q&A space opened up, so if you tab over to that, I saw in the last session that people who signed their question got many more upvotes. So maybe have a go at signing your question if you don't want it to be anonymous, and see if that helps you get your question to the top. So it's my pleasure to introduce Dr. Ryan Kidd. So he's the co-director of MATS, which is the Machine Learning and Alignment Theory Scholars, and the co-founder of the London Initiative for Safe AI. He transformed MATS from a 5-person pilot into a leading AI safety talent development program that now trains 160 researchers annually. He has experience building AI safety communities across 3 continents. He currently leads MATS strategic initiatives in AI alignment, interpretability, and governance research, while directing grants to accelerate promising AI safety projects. So let's welcome Ryan.
Good to meet you all. I'm Ryan. How you doing? Yeah, woo! Okay, good morning. I'm going to give a talk. Part of the talk is going to be a basic intro to AGI safety. I know you've already heard that, but I have my own take. Part of the talk is going to be like what we're doing at MATS and why, and part of the talk will be what can you do? What can Australia do? And I'm happy to chat about all this later, and I have a session tomorrow as well to talk more about specifics at MATS beyond what I give here. So who am I? Well, I was a PhD in physics at one point. I don't do a lot of that now. I'm not a researcher anymore, but I went to UQ. I actually grew up on the Gold Coast, and yeah, and at some point after that PhD, in fact, during the PhD, I was like, man, AI safety seems kind of important. GPT-2 is like much better than I thought it would be, you know, this like decade. And I tried to get involved in AI safety, and there weren't a lot of opportunities to do so. There's Oxford Future of Humanity Institute, there was like UC Berkeley, CHI, but there weren't a lot of like other opportunities beyond that. So I went to Berkeley, and I got involved in the pilot program of MATS, 5 scholars that were in Berkeley. And about halfway through, I was like, man, I bet I could help them grow this. So I jumped in the organizing team. The old organizing team left. Christian, my co-director, joined. And along the way, we also founded this Center for AI Safety in London called LISA, which I think is the 2nd largest AI safety office in the world now. Anyway, it's been a wild ride. And I also, at some point, started making grants via Manafund. They've very kindly given me $300,000 so far to spend on projects that I think are exciting. And there's me and some team members at MATS. OK, so first section is what is the problem we're trying to solve? So the main thing I want to articulate here, first off, what is AGI? You've heard general purpose AI, all this stuff. I like the term AGI, but there's plenty of disagreement here. AGI is AI or a machine, right, that can like do a lot of human tasks about as good as humans. Not necessarily the best humans, maybe the average humans, whatever. It varies along the degree of generality, and it varies along the degree of like how good it is compared to like the best humans. But as you can see, these benchmarks, like image classification, English language understanding, visual reasoning, multitask language understanding, and lastly, competition level mathematics are all at or approaching human levels. Many, many more are already superhuman. So AGI is already upon us in some ways. I don't think we're at the precipice for what I would call competent AGI, as Shane Legg of DeepMind defines it, but we're getting there. How are we building these things? Well, future AGI will probably be built like this. This here is a scaffold where a language model, which is trained on web text and on images, often they're multimodal, okay, is at the center of this kind of interface. It can access tools like calendars, calculators, code interpreters, symbolic reasoning engines, whatever. It can take actions like searching in the world. Already, pull out your phone. Claude and at least GPT-4 can do this. It has memory. It has planning capabilities, chain of thought, reflection, self-critics. All this stuff is already happening. Hell, OpenAI's O1 model might already be doing all this. And of course, this is the way that the 4 large labs, also XAI, are pursuing AI agents in the world. And they're just scaling and scaling. Can we keep scaling, however? Well, we seem to be 4.1x per year in terms of the log of training compute. That's a pretty far growth. Can we keep scaling, however? According to this recent analysis from Epoch AI, who are kind of the world leaders in this kind of analysis, they say yes to 2030, no problem. No bottlenecks from power, no bottlenecks from data, no bottlenecks from chip supply, no bottlenecks from latency walls and training. We're going to keep scaling. When will AGI arrive? Well, we don't know, but a lot of people have opinions. And if you look at the forecast at Metaculus, this aggregated prediction platform, the aggregation is 2032, November 2032. That's when we're going to have AGI, people. How do they define that? Well, it can pass a 2-hour adversarial Turing test where you aren't convinced whether that's a human or a model. it gets like these certain benchmark results for code generation, for language understanding, and it can assemble a model car, apparently, when you give it the right actuators. Kind of random, but there you go. I think the last one is maybe a bit misleading, and probably we'll get there sooner if you discount that. So how will AGI change the world? Well, already the Google CEO is like, hey, 25% of our code is written by AI. He boasts, right? Maybe it's not the best code, but that's a big deal. 25% of all Google code. And that is not just Google, that's across a bunch of industries. Recent International Monetary Fund report this year says that 40% of jobs are exposed to AI. In advanced economies like ours, that's 60%, half of which are automatable. Why haven't they been automated yet? Schlep. It's hard to build the scaffolding, and people don't want to spend the money on it. But it's possible. That's pretty wild. And I expect that's a massive underestimate. And we're just going to see that number rise and rise as scaling continues. Economic growth. Well, what's the first thing you might want to do with your fancy AI models, especially if you're an AI company that makes money from AI models? You might use them to accelerate R&D, which gives you better AI, gives you more money to spend on training, causes the hype cycle to continue, improves your software, perhaps improves chip design, makes better AI, cycle continues. There's this definition of this technology called transformative AI, and it's sort of like, what if we just 10x world economic growth? Wouldn't that be cool, right? Well, if you have this digital economy that is not bottlenecks, perhaps there are substantial bottlenecks on real-world resources or whatever, as we saw, not on the scale of the models up till 2030 at least. But you could imagine a crazy scenario where the world economy is almost entirely like a digital economy. I'm not an economist. I don't know how feasible this is, but certainly people are considering this seriously. Now, that would be a strange society. Also, societal change we can expect. These are 3 different types of superintelligence as defined by Nick Bostrom. Quality superintelligence, which is smarter than humans, in fact, in specific ways. Speed, which is faster than humans, which is very plausible, 100 to 1,000 times. Or collective superintelligence, because AIs are way cheaper to run than humans. You could have millions of AIs running for the same cost it takes to train that same AI using our current levels of compute we spend on AIs. Millions for the same cost. So as soon as you build it the first time, if you're willing to keep that cost ongoing, which is in fact what labs are doing all the time, you can deploy millions. Millions of the best, most highly skilled software engineers you've ever seen. That is wild. Even if there's a lot of coordination difficulties, some of those might be ironed out with more research, more time. So accelerating R&D, this is a wild picture of the world, and I think you also might start to come into contact with questions like, what about AI sentience, consciousness? Have we birthed a second species? Where do humans fit in the mix? I don't know. I'm not convinced of any of these perspectives. And lastly, catastrophic risk. So of course, we're already seeing this case where Anthropic and other labs are stress testing, red teaming their models to see how good they are at assisting unskilled people with catastrophic chemical, biological, radiological, nuclear weapon development, right? And so it's not like you can't find the stuff on the internet, but sometimes querying an expert is way better than just Googling something. So obviously, if these models aren't appropriately safeguarded, way more people in the world are going to have access to an expert they can query on how to build weapons. That seems bad. Okay, so unlearning is very important. Secondly, if we can supervise these AI models now because they're kind of dumb in a lot of ways, right? What if they're not? How are we going to supervise the crazy output of these other models? What if we put them into military command chains? What if we put them into essential cyber infrastructure? How are we going to supervise these models? And are we going to build them in ways that avoid the pitfalls associated with power seeking? Because often people want to build systems to get powerful. It's like, hey, I want to build a company. I want to make a lot of money. Inherent in that is a drive for power seeking. Maybe we're going to deliberately build systems that have properties that we would otherwise not want an unbounded, unsupervised intelligence to have. So that's the risk there. OK, so our mission at MATS is threefold. 1, AGI may be dangerous and it may be near. So we see 2032. What is the risk of AI? Well, according to the same forecasting platform, 11% risk by 2100 that 10% of the entire world's population dies. And that's just a forecasting platform, OK? But I think it's actually at 6% now, because that's from October, for complete human extinction. So this is a bunch of different catastrophic risks compared. As you can see, AI dominates both the catastrophic and the extinction risks, according to this platform. And the same applies to the existential persuasion tournament run by Tyler Cohen and the Forecasting Research Institute. where they quizzed a bunch of AI experts. They came out with 12% catastrophic AI risk by 2100, 3% of extinction. So these are not just kind of like out there numbers. A lot of experts think this. Of course, here's a bunch of other people. They're P-dooms, so-called. We have Joshua Bengio, 20% chance. Elon Musk, 10 to 20% chance. Yan LeCun, 0.01%. So opinions differ greatly in the AI space. I think AI safety is talent constrained. So if we see on the right here, we have this figure. It's the current growth rate of AI safety technical field at 28% per year. We're about 500, 600 people in the world. Maybe that again in terms of policy. That's not a lot. If we get AGI by 2032, we don't even have something by the size of the Manhattan Project until about 2040, which is before the transformative AI prediction. And of course, you could actually build a Manhattan Project, but we're not going to rely on that, right? And we're not going to rely on there being the talent kind of latently sitting around for that to just happen. And also, there's just a bunch of open roles in 80,000 hours. So many jobs available now. People have really woken up. OpenPhil, still the largest funder, way less capacity constrained. SFF, Longview, Schmidt Science Foundation is now funding this. Y Combinator and Entrepreneur First are trying to fund explainable and AI safety startups. There's so many opportunities. What are they bottlenecked on? Talent. That's what they're bottlenecked on. Lastly, we can help. So Matt says these 5 pillars. We believe in this alignment portfolio. We think a variety of alignment agendas are promising merit support. We think apprenticeship is vital as per the academic mentorship model. We think a community of peers, also from academia, is great. We think support and training can add a lot of value. And we think strong selection is important because otherwise our mentors will be doing world-leading research and not wasting their time on their scholars. So we have really strong filters there. So we want to accelerate high-impact scholars. We want to support high-impact research mentors. We want to grow the AI safety research field by making marginal hires at safety teams, at these labs, in academia, and other research nonprofits, and new founders. And all these are real examples from Matt's. So what do new researchers need? Well, they need strong technical skills. That's the most important thing, especially understanding language models and AI agents, because that is the dominant paradigm, and it's probably the thing that's going to build AGI. So they need to have a lot of experience with that. They need high-quality mentorship. They need lots of compute, at least if they're doing technical research, because that's where the frontier is. They need a basic understanding of the AI threat models. They need community to support their people, right? They need to have a home. And for technical jobs, they need a lot of publications, and they need to be really fast at coding. Often AI PhD students aren't fast enough at coding to get jobs at frontier labs. Okay, that's a big bottleneck. And vice versa. Sometimes engineers aren't good enough at research to get some of the research science jobs. And for governance jobs, they need to have really good research communication skills. You're not trying to reinvent the wheel in terms of safety policy. You're trying to communicate the frontiers of technical research to existing policymakers in a lot of cases. That's the dominant hiring need. What do mentors need? Well, they need research assistants. They need a hiring pipeline, because these are kind of hard to build sometimes. They need experience as a manager, like low-stakes ways to fail, right? If they're learning how to be a manager, that's what we provide. And they need support to scale nascent projects that can't yet attract large degrees of funding, especially from industries that are less, they're more profit-oriented. What does the AI safety field need? Well, we surveyed 31 heads of labs and hiring managers, basically everyone in the AI safety space, and we came with these 3 archetypes. Connectors who connect research theory, so AI theory, to the empirics. Iterators who iterate often empirically on the current paradigms. Amplifiers who scale the projects. They have people skills. A lot of people at MATS are something like this. Yeah, and of course, the needs differ by organization. So the largest labs, they mostly need iterators because they have a dominant paradigm, and they sometimes need project managers, amplifiers. Growing technical safety orgs like Meter, like FAR, et cetera, amplifiers over iterators. They've grown to a point where they need people managers who understand the technical skills to leverage the teams. And small technical orgs mostly just need iterators. Not a lot of need for connectors currently in the job market. Academia and independent research are the main areas where those people add value. That might increasingly change as a lot of research engineering is automated. Who knows? So what is our strategy? Well, here's the 5 kind of parts of the MATS pipeline: advertising, selection, training, offboarding, and our alumni network. And I'll just focus on training for now. If you want to see the rest, we can talk tomorrow at my panel session. So the MATS program is a 10-week, twice-a-year program in Berkeley, California. It's near UC Berkeley, but it's not at UC Berkeley. It consists of mentored research projects. We have an office we spin up and down. the whole community. You can see some of the presentations there from our symposium and the career fair. There's seminars, there's workshops, there's the kitchen sink. Research management is another feature I'll mention in a moment. And of course, it's followed by this extension phase of 4 to 6 months for about half the scholars. So what is research management? Well, it's a person at the nexus of the mentor-scholar MATS team relationship. They meet weekly with mentors, scholars, and the MATS team. They help scholars set goals, be productive, use mentor time well, sort of like borrowing the people management side of project management. They help mentors track scholar research, and they help MATS achieve our program outcomes like our milestones, grant submissions, et cetera, for scholars. So how have we done so far? Well, since we started in November 2021, we've supported 298 scholars and 75 mentors. Some of them have come back, about 15 people have come back and done it again. And so those numbers, just the 1.0s, 2.0s represent the solid programs, and the X.1s are the extensions. And our last program was 90 scholars, and our next is going to be 80, because we think we went a little bit too hard. So what are they doing now? Well, 78% are still working or researching in academia, AI alignment, or control. Small minority are working on what they call AI capabilities. And about 35% alumni have been hired post-MATS, which is fantastic. About 40% of them said MATS made it much more likely to apply to the job, and 24% said MATS helped them build the necessary career capital at least 6 months faster than the counterfactual. And of course, alumni have founded Apollo Research, Timaeus, Leap Labs, Center for AI Policy, Cadenza Labs, Atlas, Simplex, and I think Prism Eval and more. And 75% of alumni apply for independent research funding are successful. So what do people think? Well, scholars give us 8.9 out of 10 on average and a net promoter score of 67, which is fantastic. Mentors 8.4, NPS 45, and of course you can see the quotes. Marius, who's the CEO at Apollo, says, Apollo almost certainly would not have happened without MATS, which is fantastic endorsement. Thanks, Marius. And Stephen Casper says, mentoring for MATS has been one of the most fruitful and enjoyable collaborations I've taken part in, which is really wonderful. So, some exciting MATS research. Well, here's some examples. I haven't got the paper names because they're too long. But, yeah, debate. There's this paper on debate. You can see here Ethan Perez, Akbar Khan, a bunch of MATS scholars and more, which was best paper at ICML 2024, one of the top machine learning conferences, which is amazing. I think it might be one of the first, if not the first, AI safety or alignment paper to win best paper. Check me on that. I don't know. But yeah, so that was a really astonishing achievement for those researchers. Yeah, in the ICML 2024 Mechanistic Interpretability Workshop, we had 3 spotlight papers there recently. Paper from Stephen Casper, actually, on latent adversarial training, I consider just phenomenal advance in worst case AI alignment technical safety. So, and of course, the activation and representation engineering papers, Alex Turner's team, Dan Hendrick's team, et cetera. AI sandbagging evaluations, which is like when an AI kind of falsely set, like maybe an AI is going to be, you're doing a capability assessment, you're trying to work out how good it is at something, but the AI misrepresents. It actually pretends to be worse. Now that would be an example of deceptive behavior that we're trying to avoid. So if we can detect when an AI is doing this, maybe we've solved one of the most heinous problems of AI deception. And of course, situational awareness evals, like are AIs aware that they're AIs, that they're in training, that they can we assess whether or not they have, aspects of consciousness, that's like perhaps later down the track. I don't think consciousness is a necessary prerequisite for dangerous power among AIs, but it might be the predicate for moral consideration, which is interesting. And of course, AI control in a bash agent setting. So what are we doing now? Well, we've got applications that we're currently right now in the final stages of evaluating for our winter program. 1,786. I think I see a couple applicants in the audience. 4.5% of those we can accept, unfortunately. We're restricted to 80 scholars. And 85 mentor applicants, to which we accepted 40%. And as you can see, about almost 80% of our applicants are postgraduates. So they have bachelor's, master's, or PhDs. We tend to accept only about 20% undergrads, about 10% PhDs anyway. Yeah, and as you see, 45% working, 51% students. And in terms of the interest in the research categories, you can see the applicants and the mentors are most interested in interpretability. It's really exploded recently, as evidenced by the NeurIPS workshop, et cetera. But mentors are mostly interested in evaluations and the oversight and control research. There's still a lot of mentor applicants. Governance and strategy has like a smaller position here, which is kind of sad. We're trying to further that more. I think part of it is that we're kind of entering that space. We've been a technical program for so long, it's harder to break in. Of course, agent foundations and cooperative AI have relatively little interest, but that's still substantial. So here's the research portfolio we decided upon in consultation with our advisors. So we have mentors from all these institutions: Anthropic, DeepMind, Redwood Research, UK AI Safety Institute, Center for AI Safety, Apollo, FAR, MIRI, UC Berkeley CHI, et cetera, and a couple governments institutes as well. And the portfolio in terms of our scholar headcount is going to be something like mostly oversight and control, then evaluations, and then interpretability of models, the governance of models, and studying the agency properties, like the emerging properties of AI agents and what the foundations of agency are. So, and this portfolio has changed. It's kind of moved away from interpretability as we've kind of like refocused more on this like near-term language model agents paradigm, and of course building like red teaming and control research to steer these language models. So how can you help? Well, I have about 9 minutes here, and I've got like 2 slides. I might have gone too fast, so I'm going to take it easy and go through these slower. So here's the generic slide. Got to do it. You can apply to MATS. We're still taking. We'll take applicants for summer relatively soon. Mentor applications are open now. If you want to be a mentor, let me know. We're just finished our advertising for new team members, but we tend to hire periodically every 6 months. If you're an amplifier type, that might be useful. If you're a researcher who wants a break, you could donate to MATS. We're a nonprofit 501c3 in the US, and we could use all the funding we can get. And the Long-Term Future Fund as well, which makes grants to independent researchers for AI safety. And they're critically funding constrained now. You can also host a local AI Safety Fundamentals reading group, really advocate this course sort of like a almost necessary prerequisite for getting into MATS. We think this just gives you the minimum viable understanding of like what's going on and why. Also, there's this Alignment Research Engineer Accelerator course, which is pretty good, which has helped a lot of MATS scholars. And that curriculum is free online on GitHub. And I believe Yanni might be trying to organize one for Australia as well. You could work on high-impact research. More on that later. I guess we could talk more about that. You could build aptitudes in industry and academia, and then just kind of get laterally hired into high-impact roles as they emerge. Perhaps as there's a regulatory market or other types of maybe there's an AI Safety Institute in Australia that you could join. So I'll talk a little bit about Australians for AI safety, what my thoughts are here. I think like the dominant 3 things for Australia are research and training. There's a lot of fantastic people come out of Australia for this. Australian AI Safety Institute, of course, and international diplomacy, as was highlighted earlier. So from the first point, Australia has like 7 out of the top 100 computer science universities. That's non-trivial. There's a lot of great computer science work in Australia. And you can always run these local training programs. And of course, you have the Good Ancestors Project, Great Institute, Harmony Intelligence. I think all of these projects are fantastic. And there's room for more. There's more funding out there, as I pointed to. We might have hit our stride for nonprofit funding. What could an Australian AI Safety Institute do? Well, as the UK AI Safety Institute has shown, there's a great potential for these government institutes to do world-leading research on evaluations and control and safety cases for models. This is really good. They can like do this kind of external red teaming or threat assessment from a very strong position of authority connected to government of the leading labs' models. They get privileged access to the models and evaluate them and publish their results. And of course, Australia is also a member of Five Eyes and is a NATO partner. And so there's a lot of reason to think that US, even if there's nationalization of AGI development, which I might touch on, that Australia could play a prominent role here. It's also just a great place to like absorb talent. One of the bottlenecks in scaling AI safety seems to be people who can like found new things, who can like apply to funding. Like often the best researchers are not the best founders. And founders, like when you're selecting for founders, there's almost kind of anti-selects against people who are more altruistically motivated. Unfortunately, like a lot of the kind of drive to found things and build industry like has like also this, people want to make money, VCs want to make money, et cetera. It's kind of rare to be both a founder and be like, nonprofit kind of driven. So yeah, I think AI safety institutes could do a lot of good. I also think Australia has a great role to play in international diplomacy. As I've said, NATO partner, Five Eyes member. I think in terms of like world AGI development, I'm not sure, who's read Situational Awareness by Leopold Aschenbrenner? Okay, so a few people, all right. So that paints a pretty wild picture of the world where the US and China are racing potentially to the brink of AGI development because it would offer a decisive strategic advantage for military or economic technology, and even a gap of 3 months would be so, in terms of that recursive improvement of AI, by AI, that would be like just insurpassable. There'd be no way to surpass a 3-month gap. So that's a scary prospect. Certainly, if we're going to slow down and avoid that kind of brinksmanship, having really good intelligence sharing on who is building AGI and like how close they are might be good for that. And of course, Five Eyes does that kind of intelligence sharing. And yeah, there's like, to the extent that the AI race, I don't like that term, but if there is something that approximates that, yeah, I guess like avoiding brinksmanship with international coalitions seems very important. And yeah, I think that Australia has a strong role to play here as a middle power or something. We're a strong trading partner of China, especially for thermal coal. How will AGI be built? Well, Leopold talks about $100 billion, maybe $1 trillion data centers built by national or soft nationalized labs, like you can imagine. Anthropic, OpenAI, XAI, Meta, whatever, they become the Boeing, the Lockheed Martin defense contractors of the US military industrial complex, in his vision anyway. And in those situations, it is in fact an industrial process to build AGI. It needs a lot of power, right? It needs nuclear power stations. It needs like, I don't know, coal seam gas. It needs like a huge amount of resources in those pictures. And I think Australia has a substantial role to play on the world stage in terms of advocating for international treaties, perhaps against fast or unsafe development of AGI technology. So I'm a little bit under time. I can talk a little bit about, I'm just going to go quickly into, I'll jump back to what talent is needed because I have a bunch of slides here. So as I said, machine learning skill is very important for the technical roles. New talent can seize low-hanging fruit. There's a huge amount of low-hanging fruit in the technical space, obviously in the policy space too. We've increasingly recommended some of our technical people start going into policy, and that has happened at UK AC and other places, and RAND and so on. But yeah, the indirect object identification or the sleeper agents paper or sparse autoencoders of activation steering, people working on those projects like 6 to 12 months experience, and then world-leading research. There's a huge amount of low-hanging fruit. Fast coding, as I mentioned, is very important for scaling lab teams. And that does seem to be where most of the AI safety research is happening, is on those teams. Because compute, even for things like interpretability, the dominant approach is these sparse autoencoders, these really, really wide layers of models. You need a lot of compute to train the best sparse autoencoders. So it does seem like increasingly all paths to AI safety are kind of converging, apart from maybe more agent-based approaches, which I think are somewhat of a side bet in my portfolio. All other paths are converging to need a lot of money to play. And so academics might be priced out unless there's a lot of great government or other nonprofit funding they can access. And that's why a lot of academics like Sam Bowman, NYU, went to Anthropic to co-lead their alignment science team, many other such cases, because in fact they have the best toys. And you need the best toys to play. Of course, good research communication, very important. This is a huge bottleneck on getting policymakers or the general public to kind of really buy into the risks and understand what the trade-offs are of developing these technologies faster or slower. There's many high-impact roles outside of technical AI safety. Policy is probably the dominant need for talent right now. There's some policy roles I expect existing policy professionals just to kind of sideline into, but they might not have the technical background necessary to unpack the frontier technical research in a way that policymakers can understand. So if you're a technical person and you have some of those communication skills, this could be a fantastic way to add value at the frontier. And of course, operations, like my organization and many others, are critically bottlenecked on great operations management talent. Honestly, it's just such a huge bottleneck. So if you've ever considered that career, that could be for you. Or if you know people who are great operations managers or project managers in industry, and they want to get involved in AI safety, perhaps for nonprofit wages, but send them my way. I'll see what I can recommend. Or it's 80,000 hours. They love that. And lastly, academia, I think, is extremely underrated. If they're critically bottlenecked on compute, let's give them the money. Let's find a way to make it happen. And futures where AGI development is somewhat of a nationalized pursuit behind kind of firewalls. Already, it's all quite privatized. We can't see a lot of what happens. People have stopped publishing at frontier labs, basically. But in those situations, maybe some of the best places to work might be in academia if they have enough funding, because then you could do research on maybe not the frontier, but the best open source models, do some safety techniques on that, and hopefully demonstrate evidence of scaling. And then publish your safety techniques. And then maybe people, the military projects or the government projects or the private labs, whatever, can see what you've done and pick that up and apply that to their models for safety. So thank you for coming to my talk.